This assessment asks us to rank chair structures based on which one is more stable, given a particular line angle drawing of a cyclohexane ring. I've already taken this given structure, line angle structure, and converted it into its two chair structures. That's not the point of this particular assessment. Having drawn these two chair structures, what we want to do is decide which one is more stable given between these two. The structure on the left has an isopropyl group in an axial position and a methyl group in an axial position. So that's two axial groups. The structure on the right has the isopropyl and the methyl group both in equatorial positions. So that's two equatorial groups. The ball always rolls downhill. Molecules will do anything they can to be as stable as possible. The axial position is less stable. The equatorial position is more stable. Therefore, if we can maximize the number of equatorial positions, that will make the chair structure more stable overall. That means that this chair structure on the right, with more equatorial groups and less axial groups, fewer axial groups, is going to be the more stable chair structure for this particular series.